Hello everybody, so this is again Dr. Sergey Sarkisov, okay? And today we will look into financial mathematics, okay? So I kind of typically summarize it in a class as this, as kind of a combination of a few top concepts, four concepts mainly that I consider this to be. So let's talk about mathematical finance and financial mathematics. Financial, it's like personal financials. So financial, math, okay? And what I really want to bring out today from us is this idea or this understanding of four concepts. And it gets kind of a little bit more difficult in the sequence that I'm going to present it in. So the first concept I want to talk about is called just simple interest. Okay, and so this is like, let's say you're loaning, you're borrowing money, whatever, and you have to pay for borrowing somebody's money. You have to give them something for using their assets, let's say. So and that payment is interest, okay? So anyway, there's simple interest, okay? That's just something basic and accrues over time, or directly proportional, like linearly, okay? So simple interest. Then there's something a little bit more interesting. This is actually more common. It's more difficult a little bit. It's called compound interest. It's kind of like simple interest, but it happens over and over and over again. So over a period of time, it now builds on the bigger sum that you already owe or have, borrowing. So anyway, compound interest, okay? And then interest, right? And then I want to talk about two other topics, and of course there can be multiple names for this, right? And so this is a mathematics class. Let me keep it kind of basic with the naming. We're not doing business here per se, or it's not business school. So let's say present value, okay? Present value. That's very important. And actually, present value, let me write that a little later. That's kind of the fourth thing I want to do. The first, and before that, I want to talk about ordinary annuities. So annuities. And we're going to make it ordinary. Ordinary, let me just tell you right now, ordinary is when you make a payment at the end of each period. Let's say at the end of each month. Typically, let's say you're renting, or like you're in a savings account, you're putting out money, right? Like from a checking to a savings. You usually do it after the month, right? Like, oh, like the month goes by, I'm going to put in $50. Another month goes by, I'll put another $50 into my savings account. Sometimes there's something called, let me just tell you one time, it's something called annuities due. Okay, ordinary annuities and annuities due. Annuities due is usually when you do before. Okay, so if you put annuities due or ordinary annuities, the difference is ordinary is when it's the end of the period you pay, and slightly different the formula is when you do, let's say, the beginning of each period. Let's say you come in and you're like, I'm going to pay this first payment just to make sure, not a deposit, but actually a payment. Like, I'm going to pay you $10, okay? Then I'm going to pay you again at the beginning of the next period, next month, $10, and I pay at the beginning of each period. But then I don't have to pay at the very, very, very end because I already paid off everything. Let's say the period right before the last. So the time right before the last period. So anyway, annuities, ordinary, we're going to talk about those. The ones that are after each period, at the end, okay? And this is the formulas are just more commonly seen for these types, okay? And finally, present value. And even with present values, we'll talk about something called amortization, okay? I'll give you one example of that. It's really cool and it will help you a lot. Let's say you're buying a house. You're talking to a realtor who, depending, may not be familiar with the mathematics behind some of this, and they're like, you know what, there's a formula, Google search, and like maybe they found the wrong formula or whatever, right? You're like, you know what, let me look into this, and I did some math behind the scenes, all right, here's the monthly payment I will be making if I purchase a house that's, make a loan, like I take a loan out for like $300,000 house, maybe 2-bedroom in a Houston area somewhere, kind of, in a good area, but not, nothing too fancy. And you're going to make a down payment of $25,000. And we'll do an example like this. And like, what will you be paying every month, right? Like, if the bank allows you to do that, and with an interest rate of so and so 5% over maybe a 30-year period every month, right? Like examples. So this is called amortization, okay? Amortization of a loan. Amortization. This is really cool, and this is having to do with present value, okay? Amortization. So again, I don't want to keep it too long of a presentation. So like this is obviously also going into the YouTube channel, and people usually, observers, like to kind of see something a little bit condensed, right? Usually with some kind of still like that understanding the meaning of the ideation, but something easy to follow. And let's do this. So anyway, simple interest. Let me kind of change the colors up a little bit. And I'm going to go more by example and a little bit of theory here and there. So let's do simple interest. For simple interest, okay, I'm going to say, let's say principal. So let's do example 1. Okay? Let's do simple interest. So simple interest, the formula is that if you have a present, let's say a principal, you borrow some amount of money. So principal. I'm going to write principal. Okay? And what you do is there's an interest rate, okay? And you do rate, and times, let's say rate is per, like per year, and however many years, that's the time. So times the time. Okay? That's what simple interest is about. Okay? So let me kind of write it as interest is equal to principal P, rate R, time T. Okay? And the future value is what you're going to be owing or what you're going to gain. Let's say you're lending somebody the money. Kind of that's going to be, let's say we're going to call it like future value. That's going to be the, not really present value, that's a little different PV, but like the principal, right? But so we start with principal, and then we're obviously pay interest, a little bit that builds on it, right? And I'll give you an example in a bit. So you do P plus this I, okay? So that's like kind of like what you kind of started with, and also the little extra you got, or that extra you have to pay. So you owe maybe, let's say you owe $1,000 in the beginning, and you're borrowing that. I mean, you're going to owe, like $1,200 something later after a few years, right? It builds up. It's the interest, right? So rate, interest rate. Let me write interest. So you understand the word interest is very big. Simple interest here, right? So P plus I, and that's going to be, look, PRT, P plus PRT. So P, and if you distribute it out, it's going to be 1 plus RT. That's a formula for simple interest formula with a future value, and this is the simple interest part, and this is just the initial principal. So for example, let's do this example, a little different color here. Let's say I say, you know what? We'll talk about you borrow. Let's say we have, let's say we borrow something kind of like $1,000. Make it easy, numbers easy. Okay? At interest rate, at rate, let's do like just basic. Let's do like 7%. Okay? And but you do this 7% like yearly. Let's do yearly. For let's say 3 years. Okay, so this is example, like example A. What is interest? What are interest and the total, the future value, and the value, the future value, the value there. So what you do is, let's do this. Let's do solution in red. Why not? So what you do is just plug in the formula. So what's interest? Simple interest, or SI, or just I. But SI is equal to, okay? Principal, $1,000. Okay? Then you can say, you know what? I'm going to multiply this by 7% yearly. Okay, so 7%. That's like what? That's a 0.07. Everybody know that 7% is 7/100ths, right? You can even do like fractions, like 7%. Let's just do 0.07. Again, I typically don't allow calculators in any class besides the one here when we do financial mathematics aspect or portion of it, right? Then we have to do calculators. When you have these powers, like you'll see later for amortization, there's just no way without it, all right? You have to do that to the x to the y button. You have to know how to do the powers. Let's say I'll ask you, oh, what's 2 to the 10th power? And you don't know it's 1024. You put 2, that button, and 10 equal sign, and you get 1024. We should be able to do that. But anyway, we'll talk about that in a bit. But look, and you have this, and then what? This is like per year, right? And how many years? 3 years, right? So times 3 years. So they cancel. That's the idea. The units will cancel. Per year, the units will cancel. And you multiply this out. Look at this. 7% of 1,000 is $70 times 3. You have $210, okay? And so what the idea would be is that the future value, let's put future value, is going to equal to what? You started with the 1,000, and now you owe extra 2,210. So the future value, you can usually use this formula also, 1,000, right? Put a dollar sign just for fun. And 1 plus 0.07 times 3, right? Which is going to be 1.21 times 1,000, and that's going to be, you'll see that, $1,210, or if it's money, dollars, in the United States, let's say, right? So anyway, That's an idea, and let's do a slightly different example here. Let's do example B, simple interest. I'm going to erase this eventually. We're not going to have enough board to do some of these four concepts here, but look. B, let's do an example where we're going to lend someone, this is the same thing, lend, but this is again simple interest. I should have said at a rate, simple interest rate, like, okay, so because you've got to do compound interest. It's something very different. We'll talk about that in a bit, okay? So lend someone, let's do like, let's say you have a buddy and they needed like a little bit more money, like $700. Okay? $700 at simple interest rate of maybe you'll do kind of something like annual. Usually everything's almost annual, so simple interest rate, and let's put annual, kind of like that one was annual, yearly, annual, like APR almost, but that's a little different. So annual of, let's say, 5%. Okay, so you're not going to be too tough on them. Okay, and for, let's say, like we have, let's do something kind of fun for 8 months. Okay, so this is not a year. 8 months is not like 8 years, right? So find the same thing. Find the simple interest and find the future value. Okay, and we'll maybe use these same numbers when we talk about a little bit of compound interest and so on. So simple interest, ready? Here we go. We say the principal, okay, $700. I'm going to not do the dollar sign anymore. Okay. What happens? We do the rate. What's the rate? 5%, 0.05 per year, right? And now, how many years is 8 months? Because per year, we need years. 8 months is actually, if you do 8 over 12, right? 8 months and 12 months. That's how you do years. That's actually 2/3, right? And if you multiply this out, let's see what happens. It's going to be, let's see if I can do what I can do in my head. So 5% of 700 is going to be $35. So 35 times 2 over 3, and this is all dollars, okay? Put dollars there. I just said I wouldn't, but let me do that. And so actually, the interest would be, let me see if I can do this, 70 over 3 is going to be $23.33, okay? You get $23.33. Because if you multiply that by 3, you'll get what? 69 and 3 times a third is 1, so 70, and that's kind of cool, right? So that's an idea, and of course it goes on and on and on. It's a repeating decimal, but we stop at the cents. We round it down because it's another 3 to 33 cents. Okay, so that's an idea. And so what would be future value? Let's just do this quickly as follows. $700 plus the $23.33. Oh, that's easy. Let me just do that. 700 plus $23.33, right? And that's going to equal to, let's put that in money, kind of take the dollar out. $723.33. So that's going to be what I'm getting back instead of just getting 700. That was a small interest rate, right? And it's not a long time, but still, even $23.33 is something. We can go get a bite to eat, right? So anyway, that's an idea there. That's simple interest. Okay, so I really want to get to this present value amortization. Let's kind of go on with compound interest. Now it's getting a little bit more involved. Compound interest is, let's say you're doing like, let's do this. Let's say compound interest now. Okay? Let me kind of give you a formula as I explain it. Compound interest, this is right here, this thing we were doing right there, okay? Compound interest, is when it builds over time. Let's say we have a principal, we still borrow something, right? But then what happens is, and this is a little bit more where the future value kind of makes sense right away. So let me kind of, instead of this is compound interest, but let me write this as compounded, okay? And let's say we're compounding over some period of time, compounded annually maybe, right? So what happens is, or just over, you have some periods of time, you have how many times you have in a period. Let's pretend annually for a bit, right? So what happens is, the future value, okay, the value that you'll actually end up with, okay? You start with a principal. Now, look at this. What happens is, over 1 year, like we were just doing, kind of simple interest, over a year, just, you do what? 1 plus R. Okay? Like kind of 1 plus R, right? And this is 1. T is 1 year, da da da. Okay? All right, cool. So the interest was just the RP, right? The, like for example, if it's 5%, here's 1,000, you put $50 extra. Now, okay, let's actually do this parallel. Let me share this. So parallel, we're going to talk about, let's say let's do kind of easier numbers. Okay? Let's say we borrow, principal is $1,000. It's easier numbers. Rate is, let's do easier, I mean easier, let me do a rate, easy rate of maybe 10%, okay? 10%, 10% annual, okay? Annual. Okay. Annual is easier, I'll tell you, we can do other things too, okay? In a bit. And so let's say we have years, like years, t equals 3 years. And we're doing annually, so m, like how often do you do per year? Let's just do 1. M is equal to 1. In other words, I'm not going to write it even. But so what happens is, look, initially, so let's say year 0, 1 year goes by, 2 years go by, and then 3 years go by. And like after the 3rd year, what happens? So look, at 0 we have $1,000, right? And what happens after 1 year? What do you think? 10% on top of the 1,000, it's going to be 1,100, okay? 1,100. Make sense? Because if you do this formula, 1,000 times 1 plus 0.1, 1.1 times the 1,000, it's going to be 1,100, 1,100, okay? So that's not what we owe. But now, the problem is, I'm not having another 100 extra. Like simple interest is like, oh, 1,000, 1,100, 1,200, 1,300. No, we're borrowing this much now. And so we have to pay interest on all of that. So what happens is, look, this is times 1.1, right? 1 plus 10%, so 100% plus 10% is 101.1 okay? Times. And now I'm going to multiply this by 1.1, because I'm going to do 10% of this now, which is actually $110, right? Yeah, so, because it's not 10% of 1,100 is $110. So if I do times a 1.1, we will get $1,210 total. Now that's really, see, it's a little bit more than 1,200, it's $10 even more. And then if we do it one more time, let's see if I can do this. That's going to be $1,331. Cool, right? It's a little bit get extra every time. And this is going to, I'm cubing 1.1 and I get 1.331. I kind of remember this a little bit, okay? It's a little, some tricks you can do mathematically for you. You know, that'd be really cool if you learn them. But anyway, look, this is different than if it was, this is compound interest. With compound interest. So what was the compound interest itself? Compound interest was $331. What do you do to find the interest? You would subtract the future value minus the present value if you ever needed to do that. But again, we did this for, this is just 1 year. What do you do if it's like, again, 3 years? You would multiply again and again the n years. We did 3 years. Look at this. 1 time, 2 times, 3 times, right? So to the n power, you'd multiply it by itself, by itself, by itself, n times, n years. And so you have to the, you know, to the t power, the number of years, okay? This is compound. Now, compounded annually, but compound interest, okay? And so the interest itself, the extra would be this minus the p, 1p, okay? And that's just, you know, let's just take away what you started with to see what extra was, right? So instead of it being 1,331, it will be this minus that 1,000 to give you, and that's just minus a p over here if you need it, okay? But usually future value is actually more interesting for us. So let me show you another formula. What if, let's see, this example, I'm going to get another formula in a bit. So example B, okay? What if we do quarterly? So look, we're going to borrow P. Let's do a little bit something different. Let's say we have like kind of some numbers like, let's do the same thing. Let's do $1,000. And let's do the rate, annual rate, okay, is, again, 10%. But we're going to do, this is annual, okay? We will, you know what we're going to do? We're going to pay, okay, here goes. 1 second. So this is, let's say this is, so we're going to do monthly though. Okay, this is a month, 1 second. So we're going to do, 1 second, it's going to be, yeah, it's going to be not annual rate. So this is going to be monthly, okay? We have to pay every monthly, every month. We're going to, or quarterly, I said quarterly, right? But let's do monthly. Let's do kind of examples, and so let's do this. We're going to do quarterly first, and then we'll see if we have time for monthly, but quarterly, okay? So that's what? That's 4 times a year, every 3 months per se, right? And let's do, again, t equals 3 years, okay? Now, quarterly, you know what that means? We'll do that in a bit. But look, and that's kind of like it could have been in red, but anyway, quarterly, this is m equals 4, okay? The number of times in a year you do that, or the number of periods you have per year, okay? Now look, here's what happens. How many total periods How many total periods are you paying? How many times are you making a payment? Or like how many times is it building, accumulating? I mean, it's going to be not 3 years, not 3, it's 3 years, but each year it's 4 times. So it's going to be what? Look at this. It's going to be m times t, right? It's going to be 3 4s. 4 times, and then again 4 times, and again 4 times, and this is going to be 3 times 4 is equal to 12, okay? So this is the number of total times it's going to get accumulated, or the compound interest compounded is going to be, okay? So look, what the formula will be similar, okay? But what we do now, okay, is this. Future value, formula will be, start with the principal, okay? Then we have our interest is actually, look at this, there's one more thing we have to do. What's the interest? Okay, and this is actually, so the interest rate is usually given the annual rate, right? But if we're doing quarterly payments, what happens? What's actually the interest that we are doing per that little period? It's going to be, if we're doing 4 times a year, you're going to divide this R by the number of times you're doing it in a year. Everyone? You get it? So that's like a convention. It's not exactly a formal mathematical rigorous kind of statement, okay? Like it's not something derived. People say, you know what, if our interest annually is 12% and we do it monthly, it's like 1%, 1%, 1%, 1%. It's convention. It's an easier way to just divide by 12, divide by 4, divide by whatever it is. So we're gonna divide by 4, by 4, yes. And so, okay? And so what happens now, look, is the interest rate is actually not 10%. Let's do 0.01. I mean 0.1, oops. 10% is 0.1, not 0.01, right? All over 4, and that's going to be actually 2.5%, okay? So it's 0.025. That's really what's going on every 3 months. Right? That's 4 periods, right? It's 4 semesters. Up, 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 up. 2.5%, 2.5%. So it's kind of like 10%, but it's like in periods of 2.5%. It's a little convention there. It's not exactly like, why do we do that? Because, okay? So anyway, here goes. Future value, the principal times, right? Similar formula to this. You have 1 plus, but look, the rate is now R over M, okay? The interest to I, people put I symbols, it's R over M, okay? And to the T, the number of payments power, the N power. You know what N is? MT, okay? I tell my students this, just write this formula down, it'd be easier that way, okay? And that's what you would do in that case. So let me explain this. You're gonna do like 2.5% every 3 months, and you have 12, those 12 periods you're doing that on, and it's going to be the same kind of thing as we did in the example A, okay? So what happens is this, the future value for our case will be, look, we start, it's going to be more, it's going to be more than that. It's going to be more than the 1,331, we'll see that. And I'll show you how to use that button in a calculator. So look, we put $1,000, principal. Now, we have what? 1 plus this is what? 1.025. You see that? That's the 1 plus the 1 plus the R over M. 1 plus 0.025. That's our interest with the payment. So it's like what you're multiplying by, right? Compounding. And you're doing it to the what power? The 12th power. Make sense? So you're doing it 12 times. And that's more than. It's not going to be too much more. See, that one we did 1.1 to the third, tick, 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 right? Like this was actually, look, future value was equal to, what is it, $1,000 times 1.1 to the third power, and that equaled out to be 1,331. It really did, right? And this is going to be not 1.1, 1.025, it's smaller, right? But to the 12th power, and you'll see it's going to end up even more than this. Let's check it out. So this is approximately, let's see, it's going to, not exact, I'm going to round it a little bit. Let me show you. So let's say the calculator like this. You have 2 types of buttons. I'm just going to write this, okay? The buttons you can have in a calculator are either, typically, they're like that, like a hat. That's like a to the power. And maybe my calculator, let me show you, has this x to the y button, I think. Let's see, okay? That means also just, this is the same button, okay? So what I will do is I'll click that, then I'll push one of these, push this button, one of the ones you have, and this button, 12, so 1.025, to 12, and then that gives me that number, okay, what that equals. Let me show you and calculate what I have here. Actually, make it, see, look at that, x to the y button. You see that right over here, my finger's around it. X to the y button right there, so I don't know if you see it, but look, let's say 2 to the x to the y to the 10, and it's going to give me 1,024. Because 2 to the 10th power is 1,024. So hopefully you saw that. But again, I just wanted to let you know, because sometimes calculators are the hardest things to learn anything about, right? So anyway, let's see what this is. I'm going to do the calculator on this. 1.025 to the 12th power. Ooh, 1.3448. So what we're going to be doing, everyone, is actually, I can see times 1,000, right? Just move the decimal spot 3 times. It's going to be, we're going to have 1,344. You see, it's more than that. $1.89. And 89, okay? And that's different. So that's compound interest, etc. Let me do this now. Let's go here. Let's leave that for a bit, and let's see if we have some space on the board here. We can do this a little bit here. So what happens with annuities due and ordinary annuities? These right here. That's a little different. That's really cool, actually. That's with compound interest as you're accumulating and you're making payments in addition every time. So for example, here we took $1,000, and now it's building on that. Now, what if, here's a question I have for you, like savings account type thing, like let's say in a bank or investing, whatever. Right? I put in $100 every month. So I put in $100, and then it's like, the 100 becomes, like, okay, let's $1,000, okay? $1,000, and then, you know, I'm letting the bank borrow that. It's in my savings account. And let's say over 3 years. Well, 1,000 becomes that, right? But after a month, I did another 1,000. Let me show you how that would look. So with this, we kind of did this and this. Let's look at that, right? So I'm going to do purple color here. So what happens is this. Let's do $1,000. Every time we're putting in $1,000. So for 3 years, I'm going to do, like in the savings account, I'm going to put in $1,000, $1,000. So I'm actually going to kind of put in 3,000 if that makes sense. Okay? So let's do 0 years, 0 years, 1 years. I'm going to put years everywhere instead of year. 2 years, and 3 years. Okay. So look, after I'll put in 1,000 after like kind of initially, but like again, it's after. You should do the ordinaries after. Okay. So we put 1,000 here. Okay? And then you know what happens after, let's do 4 years. Okay. So after a year goes by, again, what happens? Let's do, so again, principal 1,000. And then rate. What rate were we doing? 10%. Okay. And this is all annual for now. Okay. What happens is, look, we're doing right here, this example of ordinary annuities. Okay. It's like putting away $1,000 every year into our savings account in the bank, and it's building with an interest rate of 10% annual. Okay. So what happens is just this payment, just this one thing we put in $1,000 after that year, and then right, it's going to become what is that? 1,100. It becomes 1,210. I'm just those numbers right there. Okay. And 1,331. And you can do that with a calculator if you can't see that really quickly, right? Anyway, now after I'll put in another $1,000 in. Okay. So let's say we do this again, right? And this becomes like just this one. The next year is going to be 1,100. You multiply this just one time by the 1.1. So it's going to go like this, the same thing, but now it's starting here, okay? And then times what is that? Now it's going to become $1,210. And then let's do the last payment. Becomes what is that? 1,100, right? Just one time. And so what I'm trying to get at is if after a year goes by, like let's say 0 to 1, a year goes by, and then you're like, I'm going to make a payment of $1,000 in the bank. Sometimes you do, again, you see annuities due would be making sense as well, like what you pay initially. But like maybe you put in 1,000 and then you start counting. But let's say like a year goes by, then we put in 1,000. Another year goes by, we put another 1,000 in. Another year goes by, we put another 1,000 in. What happens in 4 years? Well, in 4 years, we don't have just what? We don't have only just the 3,000. We put in 3,000, but have, what do we have? Let's say into savings account, savings, right? Because we did 1,000, 1,000, 1,000. Well, here they are. And guess what we have now? We have into savings and then over 4 years, right? So into savings, and we have into 3,000 into savings, but we have, I already said that, but have in 4 years, in 4 years, okay, what? So 4 years we're doing like, let's even do this. So, and we also make that one at the very end payment, right? Like, let's say we put a payment in, but we haven't got anything on it. Okay, so let me make sure we understand that. So, let's just do right here another $1,000, but nothing happens to it, right? It just started. Okay? So we have 4,000 then, okay? Because it makes a little more sense sometimes for us to do that. $4,000 because we did 4 payments, and now only one of them didn't really, it wasn't affected. It just we put it in, and that's there. This one was affected 1 time. This was affected twice, and this was affected 3 times, right? Because 3 years go by between year 1 and year 4. Okay, so now look. If we have total, we have 1,000, 1,100, and if you add it up, it's going to be 4,000, yes. 641, is that what it is, everyone? What is that? 4,641, I'm pretty sure that's it. 4,641, cool, right? Now that's more than 4,000 by $641. So how did we figure out that 641, right? Like, why was it interest like that much? Okay? And so let me show you how do we do that. Then this is a little bit, I want to give you a little insight into why this actually works. Okay? So here, many people never understand this part. Okay? This is a little called, actually in a pre-calculus class, okay, this is different, it's mathematical, very thorough class before calculus usually takes place. I teach arithmetic and geometric series and sequences. Okay? Now I'm not going to give you the depth of that right now. It's kind of a little still. A lot of you are business and math students versus even mathematics, right? Inclined, but it doesn't mean you won't enjoy this and see some cool stuff out of this, right? And maybe this will give you a lot of insight and kind of even an advantage to some people who do business without understanding this aspect of it. Okay, so at least it's nice to see it at least once. Okay, let me show you what we can do here. Okay, I'm gonna erase this. I can go back anyway. It's recorded, right? So anyway, here goes. Now let me show you what happens. Okay. Why this is going on like as the way it is. How do we have a formula to not like just count it up like that, but actually have a formula for it? Watch this. Okay, here goes. When you make a payment, right? So like remember how we did $1,000 here? Like a little, like let's say savings, like we make a payment into the bank, like we let them borrow our money, right? Okay. Let's call that payment whatever the payment is, right? And it's going to be compounded, right? So payment, it's called PMT, payment, and it's going to be compounded like this. What will happen? It was compounded 1, 2, 3, actually not 4 years, but 3 years, right? Because between 1 year and 4 years. So it would be payment times the 1 plus the interest to the power n minus 1, okay? And I'm using those kind of like we had here for the compound interest power. N was MT, remember, and I was actually R over M. How many times you did a month? Imagine you're not doing just annual, but okay, so this we just did every year, so it was easier. And then look, this one would be actually that one. This one would be, we would do it, see we did this 2 times only, and this is only 1 time, this is 0 times. So we would have PMT times 1 plus I to the n minus 2. We did it, like let's say that was 4 minus 1 is 3, 4 minus 2 is 2. So 3 times, 2 times, 1 time, and 0 times, right? So you go ultimately all the way to just having it done. The compounded it was compounded maybe just once and compounded maybe not at all at the very end. Okay. So what we can do here, that's really going to be this kind of future value. Okay. All right. Now, let me show you this. What this is doing, okay, if you rearrange it just a little bit, I'll kind of give this marker, is it's going to be doing this. PMT. Let's factor PMT out, the payment. And what happens is, look, let's do it kind of reverse. How many payments? 1 payment. 1 plus I payments. 1 plus, and so on. So look at this. You have 1 plus 1 plus I plus 1 plus I. You're going to be, right here would have been this squared, cubed, okay, right? So squared, because it would have done twice, and then this is 3 times. So this way it increases. 0 of them, 1 of them, 2 of them, da da da, n minus 2 of them, n minus 1 of them, right? So cubed, and so on, it goes on all the way to 1 plus I to the, like this n minus 2. And finally, 1 plus I to the n minus 1. Let me show you a way to derive a really cool formula here. So first, how do we make this all this messy? This is dot, dot, dot. This could be like, what if we had like 10 years going on, right? This would be 1, like to the 0th power, to the 1st power, to the 2nd, 3rd, and you go all the way to 9. You'd have a whole bunch of terms, 10 terms, right? So what you would do, let me first ask you this. What do you know about, let's do this. 1 plus x squared plus x cubed plus x to the 4th, and so on all the way to da-da-da, plus x to the k power, okay? Let's see, what do we know about that? Well, I can give you a formula, but let me actually say something cool. Let's say this is a sum. Call it something. We don't know what it is. Call it the sum s, okay? One thing we can do is multiply everything by x, both sides of the equation. So what's x times s? Well, multiply everything down by x. So, for example, I tell my students, you know, like let's say you guys, I say, you know what, 3 is equal to 1 plus 2, right? 1 plus 2 is 3, so it's going to even out on the scale. 1 plus 2 and 3, they're equal, they're weighing out, right? What if I double everything? So now 2 plus 4 becomes 6, right? Is it true? Yeah, if I double 3 here, I double 3 there, they're going to still even out, right? So you can do the same thing to everything on both sides of the equation, in other words. Look, 1 times x, I'm going to multiply by x, is x. 1 plus x times x, x squared. X times x squared times x cubed. X cubed times x to the 4th. X to the 5th, and it goes on and on and on to actually plus that x to the k, and then, you know, one more of them would be x to the k plus 1. So there's an extra x in each of these, because I'm going to multiply this by x, this sum, okay? Now, what I'm going to do is I'm going to subtract the top equation from the bottom. So minus this equation plus this equation. This is kind of like linear algebra. You're allowed to do that, okay? You're allowed to do the same thing to equations. You multiply the whole equation with the same thing. You subtract one equation from the other, or constants of it, okay? So anyway, I'm going to subtract the top from the bottom. It's like, think about it. If I have 5 equals 5 and 2 equals 2, 5 minus 2, which is 3, is 5 minus 2, which is 3. They're still equal, right? So if I subtract this minus that, it's what? xs minus s. And that's actually, if you factor it out, anybody see what that is? S times 1 minus, x minus 1. You see that I'm factoring s out, x minus 1, okay? Okay? Yeah. And then this is equal to, I know I'm going a little quickly here, maybe you can review or we'll go look back if you need to, but I want to really finish this and, you know, not in over, you know, too much of time here. So anyway, what about this? Well, this minus that goes away. This minus that goes away. Look at this. This is very important. These cancel when I subtract. Cancel, 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 cancel. And guess what we're left with? This minus the 1. Right? Let me actually just write this again. So I would say, you know what I'm going to do? I'm going to write the top equation again. I usually do this in the classes. I will write this top equation again, just underneath it. S is equal to x to the k plus x to the k minus 1, right? That's what we're missing there. Da, 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 plus x to the 4th plus x cubed, right? Plus x squared plus x plus 1, okay? And I'm going to subtract, that's what I was trying to do, subtract the top one, but it's probably subtracting is easier when it's a little bit at the bottom, right, beneath it. So I'm going to subtract this equation from that one, or like this is the same as that one, okay? And so look, this, what happens? This goes away, this goes away, this goes away, this goes away, because we subtract the same thing from the same thing, right? And then we're left with everything. We're only left with this and that. And so look, x to the k plus 1, you see that? Minus the 1, there was a minus 1 there. Is equal to, all this other stuff canceled, is equal to what? X times s minus s, so it's s times x minus 1. How do you find what s is? Let's just kind of rearrange it. Sum is equal to, I'm going to divide both sides by x minus 1, x to the k plus 1 minus 1 all over x minus 1. Okay? That's a really cool formula. All right? Now, remember for us, what happened is this. X, I'm going to call this x, equals 1 plus I. Do you see that? Because it was 1 plus I squared, 1 plus I cubed. It's like x squared, x cubed, right? And so let's do that with 1 plus I. It's 1 plus I. Now, k was like n. What's n minus 1 plus a 1? N, the 1 plus 1 cancels, right? So minus 1 plus 1 cancels. So you have this k plus 1. Look, k is n, this is k. So k is equal to the n minus 1. N minus 1 plus 1 is just an n. So we have this over that. And what's x? Well, x is again 1 plus I. N minus a 1, okay? You know what that is? Let me actually write this so you here, since we're going to have an extra step anyway. I'm going to say k is at n minus 1. And then we have a plus 1, right? And then there's a minus 1 here. So what happens is, look, it's equal to, the sum is equal to, look, 1 plus I just to the, this one's cancel, so it's n minus a 1. And what is this? The one's cancel over I. Okay? So we're about to get a good cool formula. The cool formula is that the future value is the payment times all this. The payment every month, every year, whatever we're doing. So look, the formula is future value is equal to payment. And then this right here is right here. So that's what it is. Just copy that, and that's what we did, all over I. And let's check that. Let's check. Is this a messy formula that's just am I making stuff up, or is this actually real? How do we check this? Let's look at that example. All right, that example we had right here. See this one? We had an example. Let's see how we can see this. Yeah, we can see this. So the future value, the payment was equal to $1,000. Remember, every time, 1,000 at the end. So it's an ordinary annuity. Right? We're going to do 1 plus I. What was I? I said 10%, right? So, but yeah, we'll just do it for years and annually, right? Okay, so 1 plus 0.1, let me just put 1.1 then, okay? We even did 1.1 everywhere, remember? 1.1, 1.1, 1.1 to the 4th power, okay? And even though I'm doing it 3 times maximum, that's, you see that 4 minus 1 becomes just a 4. So it's actually, that's good. We know if we do it 4 years, we're going to put a 4 in, not a 3. Okay, so 4 minus a 1, and what's this? What's the interest rate? It's 1%, 0.1. 10%, I mean, sorry. And that's going to equal to, let's see. Let's do calculator. Pretend I don't know what's going on. Because I know what's going to be. 1.1, x to the y, or that hat button, and you get to the 4th power. And then you subtract the 1, you divide by 0.1, you multiply by $1,000. And you have $4,641. Surprise. $4,641. Yep. And that's exactly that. $4,641. You can put 0, 0 if you like. Huh. Cool, right? Same thing. Smiley face. Yeah? Okay. So what we can do typically, here's a formula that really usually almost always works. Not almost always, it works always. It's a little different. If you have this, by the way, this is all with compound interest at this point. You see, this had this compounding effect going on, okay? And so for ordinary annuities, the formula would be typically a little bit more involved. If you had, remember, think about it. We talked about, let's say we're doing monthly payments. Not necessarily annual, not every year. You know how like in a savings account, I put away like $25 just in a savings account every time. I think I have to actually have my credit savings account open, right? So it's like the minimum. And so every month, so remember the M, how many times a year you do it? So what you do is you do the same thing. You say, payment I'm making, and then I'm going to do 1. Remember this, everyone? What's 1 plus? It's the interest is going to be the annual rate divided by the number of times you're doing it. That's like 12. Let's say it's every month. And then I'm going to do the power what? The total number of periods, right? So let's do, if I do M times every year for T years. Remember that we did that similar form for just compound interest. Now it's going to be, this is for future value of an ordinary annuity. Take away the 1, I'm just doing this right here, and all over the I being the R over M. This is our formula, everyone. So this is the formula I would teach you typically, or teach in my classes when we're doing a little bit of financial math. Usually finite mathematics is what we would be talking about this in, all right? So, okay, that's this right here. Now, amortization of a loan. All right, this is a little trickier. Okay, it took me some time to really grasp it enough to be able to teach it comfortably. Okay, so here it goes. Let's actually write here the best we can. I need a diagram a little bit like that. So let me kind of change colors just so we can kind of have a little bit more understanding what's going on. Okay, so there's something called present value. And what that is similar, but it's going backwards on compound interest. For example, let's say what do I have to do now for later making payments of $1,000? Here's what I'm trying to say, so you'll see. Let's say we have 0 years, 1 year, 2 years. So this is like now, present, right? Present. And it's like future, kind of like we used to say future. But now present value is what matters, okay? It's like, here's an example, okay? I'm buying a house. After the down payment, a bank gives me a loan. Like, let's say the cost of the house, let's say you don't make a down payment or you already did, $300,000. And you're like, all right, well, how much am I going to be paying? I'm going to pay a lot more, am I not, right? If I'm paying monthly every month. But so look, what happens is this. They're taking care of this. We're taking care of this, okay? In other words, let me show you, okay? So let's do 3 years and 4 years. So what happens is, let's say, after a year, I pay $1,000. I'm making a $1,000 payment. Okay. What was it really before? Where have this come from? Let's just kind of think of it that way. Okay. It would have come from. Let's say we have interest rate of 5%. Okay. Now let's do 10%. We're doing 10% so much. Let's just do 10%. And let's do everything annual for a bit. Okay. So, all right, make a payment. Let's kind of, let's just put it kind of here, right, between the 0 and the 1, so it kind of it's present. We make a payment of $1,000 for it. Now, the next one, that's $1,000 you have to make. It actually came from what? Not 1,100, but you would have divided. It would have been actually 1,000 divided by the 1.1 everyone. Okay? Because that would have multiplied by 1.1, giving you the 1,000. So what is that? That's about, I'm going to explain. You'll see how it makes sense when I do it, right? It's kind of going backwards. It's $909 about, right? So let's say it's like, this is equal to $909.09. So, it's messier numbers, but it's okay. $909.09. So, okay. So you see 1,000, okay, 1,000. This is not, that's smaller. So when they give us this much, we're going to be paying that much. This is like the cost of the house. This is how much we're going to be paying. Okay, so for example, let's say we're paying another $1,000 later. Because remember, we're borrowing, so we're going to be paying. We can't just pay everything right away. So we're going to be paying 1,000, 1,000, 1,000, but over a long period of time, and it's going to be a lot more than just like the $300,000 house. And you know this, but you don't know why. Maybe the formula is what it's about to be. So let me show you. Here, this would have been actually, from the 909.09. And if I divide again by, this is actually the negative first power, if anybody knows. So if you do this, and you divide again by 1.1, and that's so squared, right? That's going to be this kind of, what is that? Divide by another 1.1, 826. So imagine, as they give you $826.45, you're going to be paying that much. So this is what they pay. This is all, like, the house costs this much. But look at this. So for example, the house costs $1,909, and this is less than $3,000, but you're paying $3,000. It's going to be a lot of stuff you have to pay, right? And so let me look at something one second here. It's going to be, let's say we're not going to really talk about this, because even that was, I should have put the in one year right there, because we're doing an ordinary, right, usually. So like let's say, lower this a little bit. So this is our first, that's the first kind of payment we're going to make after a year. We go, right? First payment. They only give you this much. So this is actually the payment, the present value of the payment that will be that actually after the first year, or first month, or whatever, right? This is the present value of what will happen after 2 years, where you're making that second payment. What about the present value of the third payment? Let's call it the present value of the third payment. Okay, that's going to be, that's 900. What is that? 909.09, and then that's going to be 826.45, and then another time. Let me erase this now. Okay, it's a good formula though. And you're going to do this one more time and divide by 1.1 to the third power. So it's going going to be 1,000 divided by 1.1, which is actually to the negative third is what that means. And that's going to be about, let's do this, 1,000 divided by 1.1 to the third power, 751.31. Okay? So this is like if you add up this, all right, watch this, let's add them up. 826.45 plus 909.0909. You are actually saying present value here, okay, is equal to $2,486.86 when you really paid $3,000, unfortunately, right? So we paid, but we would pay the entire, right? This 1,000, this 1,000, this 1,000, because 3 months you're paying 1,000. And so that's like, oh no, kind of like taxes or whatever, right? Like this is like the interest on your house, so the interest on the loan, okay? And so, oh no, right? Sad face, but, oh, sorry, 3,000. So we paid a lot more than $500 more. This wasn't even that much, seemed like, but now that's becoming a lot more. So this is like compound interest this way, present value this way, okay? So let me show you what happens here. Here the formula, let's do another color, okay? You see how this is like, we're dividing now, right? Let me do kind of this way, okay? So because we're dividing, okay, everyone, this is negative first power. Okay? Watch this. So we have, notice what we did here. This payment, and we did it to the what? 1 over, this is x, let's say, like 1.1 is x, remember? And then plus a 1 over x squared, plus 1 over x cubed. You see how we did that one, x cubed? And so we would do it how many times? We would do it 1, 2, 3, all the way to n. We'll make n payments n times. Actually, let's do 2,000. Okay, let's see what happens. I think this is a little bit messy sometimes, the formula with if you do it at the end of each, right, usually you would kind of do that. So you do it n times. And then this actually, dot, dot, dot. Let's put like, ellipsis here. Plus 1 over x to the n minus 1, and finally plus 1 over x to the n, okay? How do we find this? It's a little different, right? Okay, let me show you right here. You see how we did that? 1 plus da, 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 we get that sum. Let me show you another, let's not do the payment yet, okay? Let's call this a sum S. We got this, we got several, we got it. Okay? Now, ready? What if we multiply everything by x? Let's do it. Let's do the trick we did here. Remember that cool trick? Okay. Let's multiply by x. It's my way to do it. It's a little different than the book ever does it. Okay? X times 1 over x, that's a 1. This is plus a 1 over x. This is a plus a 1 over x squared. Plus da 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 da, and this is going to be plus a 1 over x to the n. Minus 2, plus a 1 over x to the n minus 1, right? Because the x over this is 1 x less of there. Okay? It's a little tricky, make sure you check that. But now what we're going to do is we're going to subtract, everyone. Let's just subtract the top minus the bottom. It's easier to see. Really, you should do the bottom minus the top, because remember, x is a bigger than one number. So, but anyway, watch this. Let's subtract. So, let me just write this here, actually. Everyone, let's see if we can follow this. I'm going to add this equation. This whole equation. I'm going to add this whole equation, so I don't have to rewrite this down here, so we have some space. I'm going to subtract this. I'm going to pretend this is down here and I'm subtracting it, but subtract this whole thing in brackets. So take this and minus this, okay? This and minus that. This and minus that. So look at this. What's xs minus x? Minus s, I mean? Let's write that. And that's going to be what? X minus 1 times s. You see that? Factor out of s. Distributive property. xs minus s, xs minus s. And then what does this look? 1 is going to remain. Minus. Okay, look. This goes away. Oh, minus, that's going to be, we're subtracting this. That's left. There's nothing to cancel it. Okay? Minus a 1 over x to the n. Okay? So, ready? Our s is now equal to, you see that? Okay. That's 1 minus, you know what that power n at the bottom is? It's negative n power. X to the negative n. And all over x minus 1, right? Divide by x minus 1 both sides. X minus 1. All right. Let me show you. Remember x? You remember what x is? X is going to be that 1 plus the interest rate, right? And so if you do this, you would actually get, let's do this. Well, let's remember this formula. And so look at this. When you do the future value, ready? This was again, remember this was ordinary annuity. This ordinary annuity formula. We have going to leave it here. It's kind of cool. And then finally, ordinary, and finally the present value formula. Here it goes. This is like the house amortization. Make sure we understand this now this is right here. Okay? So present value. I'm going to do an example with it. I'm going to call it soon enough. Okay? It's going to be every payment you're making, right? Because there's a payment in every one of these before that, right? Payment times $1,000 times everything, like times all this stuff, right? So payment, and then in front of it, and then times. Here goes. Okay? You see this formula? 1 minus. Now, if you think about it, x was this 1.1. And then we talk about that. That's 1 plus interest, right? And the interest, if you do it like in several times, m times every year, it's going to be the annual rate divided by m. Okay? But look, n, it's not n, it's negative n power. N was the mt. Remember the number of times the number of years? So mt all over, okay, this is actually not so bad. Look, what's 1 plus r over m, that x, minus just a 1, just the r over m. Okay? And so there, that's the I, that's interesting. A lot of times in the book, you'll just have like n here and I there for the whole thing. But I want to really give you a good idea of what's going on. This is our present value. Like amortization, let's say, of a loan, okay? Present value. It's really cool. This toughest formula. You see, this is not an easy formula, and it goes in a weird way, not even from here, but even tougher when it's going backwards. When you're going, you see the payments are going backwards on them. So again, I want to give you an example before I call it, right? So you're like, you know what, like, hey, I got it a little bit more than just like, let's see some weird formulas. So let's do it right here. Here we go. We already got that. That's a present value. Here we go. Before we say a little check mark on it. It's kind of not erasing too well here, but let's get this. Watch this. Let's talk about a house. Okay. You buy a house, what, $500,000? 3-bedroom in a good area? I don't know, depending on the inflation and whatnot. But I mean, you know, Houston, we're in Houston right now. Depends on where you are. I mean, but $500,000 is, I don't have that. Like, I mean, so, you know. But maybe somebody does, and they're like, you know what, I want to, or like, I can afford a house and pay payments on it. Let's see, what would be the payment if you are buying a $500,000 house? So look, let's do this another. Hold it, $500,000 house. So the value of the house cost, let's say cost, right, is equal to $500,000, $500,000, right? Okay. Now, what's the monthly payment if, let's say, okay, we'll do 2 examples parallel, okay? I'm going to say, so you do, okay, let's do this. And, you know, like right now, maybe it's not as easy as the COVID times. You have an interest rate maybe of, let's say 6%. Okay? Like maybe not financing yet, but like, you know, it's not the best, but it's APR, okay? APR, I'm actually APR, annual percent interest. APR. Okay? That's R, what we call it R, okay? Annual. And it's, let's say we do monthly. Monthly. So what does that mean? M is equal to what? 12, right? Every year. You don't have to do monthly, but usually people do monthly payments on a house, right? Monthly. We're going to make a down payment. Let's do something like that. Okay, down payment. Because, you know, to get a house, to get them to give you a loan, like a big loan, they want to see you can actually pay something, right? So you have some money, so you're kind of like, you know, you're basically, they're checking to see if you actually can be trusted, right? It's kind of that credibility. So down payment of, let's do like 10%. It's a lot. I mean, not everyone has $50,000 right away to give, but you know, some people may need that. So I mean, 10%. So they kind of like say, you know what, at least make a 10% payment if you want to get, and maybe you're doing this for 30 years. I just want to show you how intense this can be, okay? Like you're going to be paying for 30 years. T is 30. Okay, all right, y'all ready? Here we go. Let's go backwards. Remember, think about it. We don't know the payment, we know the present value. We are almost in the present value. So the present value, what's the present value? First of all, present value is equal to the cost, right? Cost, minus the down payment, right? You would pay off the down payment. So that's like 1 minus the down payment. What do I put? 10% down payment rate. And so, in other words, what is that? What's 500,000 and 1 minus 1%, 10%? It's going to be $450 left. Okay, so you can even do the 450. Let me not confuse you too much. Let me erase that and just say, you know what? It's going to be, not to write formulas. It's not really something you write any formulas on. So 500,000 minus the 10% of that is 50,000, right? Okay, so that's equal to 450,000, right? So equals 450,000. I'm going to not write the dollar sign for now. Okay, equals the payment that we actually are carrying to make every month. But I mean, we're trying to see what we have to make times. Here we go. That formula right there. Let's see what happens. Let's put some space on it. Okay, we have ready. 1 minus. Oops. 1 minus. That sounds fun. Now we're going to do this. 1 plus, APR 6%, but we're doing it in 12 months. So 0.06, actually it's not a bad number to figure it out in your head, but this. Now here's the question. How many payments are you making? 30 years, 12 months. 30 years, 12-month payment, right? So 12 payments. 360, everyone. Right? Like, let me make sure you understand where that comes from. Some people don't understand the 360. Again, it's because you're doing 12 times every year for 30 years. Okay? And then all over, so that's that negative power right there. All over, and that's not too bad. What is this? Just see that R over M? So kind of the monthly rate over 12. Okay? So what you can do is, you can compute this number, remember it, divide both sides by this by that, and you have the payment. Or there's a formula, of course, you can bring this over here, this down there, right? It's not that bad. But so the payment is, let me tell you what I'm going to do in the calculator. Right? Is approximately, I'll be honest, this is going to be a big payment, all right? And I'm actually going to see how much are we going to really lose if we didn't, since we didn't make a payment right away of 500 or the $500,000. But we did make 50,000, right? What is it that we really, really having to pay? Instead of paying 450,000, how much did it really have to become? How much are we really having to pay in the long run? So that's going to be the 360 payments times the however many payments, right? And we'll see. So let me show you. This one, let me just do the red now. This example here, it's the same one, okay? I'm going to calculator, and here it goes, right? Here's what I do. I'm saying, you know what? It's 0.06 divided by 12, which is 0.005, right? I'm going to add a 1 to it. Yeah? I'm going to take it to the negative, so to the power, and then 360 negative. Okay? I'm going to subtract it and add a 1, so negative and plus a 1, so 1 minus it. I'm going to now divide by this right here, which is 0.00, what is it, 005 or 0005? 005, yeah. Okay. And then we're going to, I have a 166.79, right? I'm going to flip it 1 over x button. It's a little tricky, so I don't have to write anything down on the board. And then times, so I flipped it and it comes over here, times the 450,000, okay? And guess what? The payment is, it's a big payment. I mean, it's something that's doable, but it's like $2,697. And think about it, there's also going to be mortgage and, like, I mean, the HOA, right? The homeowners association kind of the fee, right? That could be big every month, depending on where you live. There could be the taxes, right? The government, the federal and even state taxes. But 2697.98. 2697.98. That's the payment you're making every month. I mean, it's doable. Some people make that, you know, somehow. And to get, let's say, if you have a triple-digit salary, it's doable. I mean, it's hard to save too much, you know, with having this payment, and especially the HOA and all that. It's gonna be at least, it's gonna be about half of your monthly payment, but at least, right? But we'll see anyway. So let's do this. So that's the payment. We got it. Let's see how much are we gonna pay over time. total we'll end up paying in 30 years. It's going to be 360 payments times this, times 360. Okay, you're going to pay out 271 and 85 cents. And do you understand, everybody? This is almost $1 million that you're paying versus paying that 450 that you had to do a little bit more. This is more than double that, okay? And that's because this is, taken to the 360 power, and even this is just a 6% interest rate. You now realize that some people want to pay off right away. Problem is, if you pay off right away, what happens? You don't have any money to pay medical expenses right now. Maybe you have other credit scores, low debts, and all those things that are going to go down or hurt you. So that's why people kind of contemplate. Do you want to do 30 years, or maybe you want to do just 10 years? If you do 10 years, smaller number there, it's going to ultimately be a bigger payment, but you're going to do a less amount of time. Let me show you this. Well, last thing. What if we did, watch this. So you say, let's do 10 years. You're like, you know what? What's the monthly payment? Yeah, because if you're doing 10 years, you have to pay bigger payments every time. But what's the advantage? You pay ultimately less. Okay, so watch, let me show you. If you do this, the payment will be, okay, watch this. I'm just going to the green is the same as red, but now it's purple stuff, but now in green. So the only thing is you would have, for 10 years, so you put a 10 here, right? Okay, so you put a 10 here. That's why the 120, then let me do that real quickly. So we have to restart over here, so 1.005 to the negative 120 power. Oops, 120 negative, cool. I'm going to minus it from a 1. I'm going to divide that all by 0.005. I'm going to flip it around. I'm going to multiply it by the 450,000. Okay, it's going to be a big payment, almost $5,000. I don't know if you have that, but I don't. But it's not that easy to find that for me. So $5,000, 592 cents. Okay, so now how much are you going to pay up total though? This is going to be less because you're doing 10 years for 12 months. So 120 times this times 120, and it's going to be 599,000. This is a lot different than that whole million, right? So maybe 10 years is a lot better for you to do, but maybe you don't have that to do that every month, right? So then you'll just die and that's it. I'm kidding, but So 5,995, 10, and 510 and 71 cents. So that's if you do 10 years, and this is ultimately end up paying this instead of just, so you still have to pay more because you're borrowing from the bank loans you that, and you have to kind of pay it over time. But hopefully that was enjoyable, interesting, and understandable to some degree, everybody. It was a pleasure teaching you today. Have an amazing the rest of the day. And again, we talked about simple interest, compound interest, ordinary annuities, and I talked about a little just the idea of if they're due, the formula is a little bit off because you would have you start now with 1, but with x and x squared, so it's a little bit off on the shift. It would be a power n plus 1, and so on. But because you pay them initially or the other way around. Here we're paying them at the end of each. Okay? And so everyone, thanks for being here, and have a great remainder of the day.